Awesome,
I
awesome.
love it.
Thank you,
Love it.
Carlos, for the wonderful introduction. And yeah, thanks to Angelbeat for setting this up. Yeah, it's always great to present at Angelbeat event.
And we love having you here, Murty. So they're all yours.
Yeah, good morning, all. Thanks for joining. A little bit about me. I'm, uh, I'm Murty Chappidi, Senior Partner Solutions Architect at AWS in Sydney, Australia. I've been in IT for over 20 years and with Amazon for a little over 2 years. Prior to Amazon, I have worked as an enterprise solutions architect for a couple of large banks in Australia for 10 years. In my current role, I work with partners, helping them to accelerate our customers' cloud and digital transformation journeys and support them in building new solutions on AWS, leveraging cloud native services. And today, I want to talk to you about how we transform the way you search and interact with enterprise data, how we can improve employee productivity and help our customers find what they're looking for. So, Kendra is a highly accurate enterprise search service powered by machine learning. So, before I begin, I want to tell you why we built Amazon Kendra in the first place. Over the years, customers have come to us telling us they have two big challenges with enterprise search, no matter what applications they use. First one being very low search accuracy, meaning when people search for information, they simply cannot find what they need to do their jobs, leading to all sorts of problems. When we looked at low accuracy, we have discovered that most keyword search engines have been developed at a time where most enterprise content was actually structured content, mainly databases, data warehouses. Basically, it's all business intelligence. But since then, for years, now content is predominantly unstructured across the enterprise, anything from websites, research papers, corporate documents, policies, project documentation, and so on. So these documents contain a lot of context and concepts that can be understood, and keyword search engines have introduced some level of AI, like natural language processing, to extract entities, map them onto flat indexes, and use the same algorithms to help users search for information. But users often find either too little or too much information, and in many cases, it's not relevant. So let's understand the impact of low accuracy. So when people cannot find what they're looking for, it reduces employee productivity. So they're spending a lot of time searching for information rather than doing their jobs. So it increases the risk and liability of non-compliance, and it can create a lot of repeat work. The second challenge is the complexity of implementing enterprise search. The big problems of complexity turns out to be mostly focused on the fact that information scattered across a lot of different data sources across the enterprise, and pulling all of this together into an index that is searchable is a challenge by itself. And then if customers are able to do that, they end up with the same keyword search capabilities that keyword search engines offer, and making it very difficult to actually find what they're looking for. And then as content shifts and user preferences change over time, making sure that such information or such answers do not become stale is also a challenge. So let's understand the impact of complexity. So when people are searching through websites or using like customer support self-service, first of all, if people cannot find what they're looking for, they're not going to buy it and they're not going to access it. And secondly, if people cannot find answer to the questions, that directly increases support costs, and people end up talking to the support agents who themselves are challenged by finding the right information, right answers. So deploying a search engine that can learn and improve its models based on customer specific data is a difficult, and it results in costly application development. So those two big challenges related to low accuracy and complexity, what customers have been focused on. And we decided to deep dive into these challenges and try to figure out whether we can help and reinvent those experiences. So our mission at AWS is to take our rich experience and expertise with machine learning across Amazon and put it in the hands of all organizations, every developer, data scientist, researcher. We want to simplify machine learning, and we want to make it easy for all developers to easily build intelligent applications. So as Subodh explained, we have these 3 layers of stack. I'll just quickly go through it so that you will get, it will just stick in your brains firmly. So we see that machine learning stack having 3 key layers. In the bottom layer are the frameworks and infrastructure for expert practitioners. In the middle layer are the machine learning services that make it easy for machine learning developers and data scientists to build, train, and deploy machine learning models in a single click with Amazon SageMaker. And in the top layer are the AI services that allow all developers to use pre-trained and auto-trained models to add intelligence to any application without machine learning expertise. So we have taken machine learning approach to addressing and reinventing the enterprise search problem. So that's why Amazon Kendra ended up at the top of the machine learning stack rather than as part of the data and analytics technology stack we have at AWS, such as Amazon Elasticsearch Service. Okay, let's see how we have actually reinvented the search experience with Amazon Kendra. So I'll break it down into 2 main areas. First one thing is addressing the enterprise search accuracy and helping people what they're really actually looking for. And the second is addressing the complexity issue, making the implementation and ongoing support of enterprise search much simpler and quick to implement. And of course, security at AWS is of paramount importance. So first category is the use of natural language queries. So Kendra uses natural language queries as a way of addressing the world of unstructured content. So see, unstructured content contains a lot of concepts and context within the text that can be used to hone in and improve accuracy when searching for specific information. When you read a narrative, you are able to ask questions about that narrative like, who was this person, or where is the thing, or when did that happen? Same thing Kendra applies to unstructured enterprise content. For example, you can ask a question like, what are less common COVID-19 symptoms? You will receive an immediate and accurate answers as shown here. So we understand that people are not going to change overnight and stop using the keyword queries, but natural language queries are a better option for finding what you are looking for. Another thing in the world of unstructured content is that we also realize there is no single machine learning model that would be able to always provide the best answers to any inquiry. So we put several of them under the hood. First one being reading comprehension model. So that's the model that returns an answer to your question. It understands concepts like people, places, date, time, location, organization, and so on, and is able to search for specific or identify specific answers, the most likely answers to the query that was presented. FAQ matching is another model that deals with curated content. We have a lot of curated content across the enterprise, and we have a lot of frequently asked questions that have been prepared by experts in their respective fields. The third one is document ranking provides similar results like keyword search engines, which is a list of links to various documents. But unlike traditional algorithms, document ranking model with Kendra actually provides a list of documents that are relevant because they answer your question. Okay, so now in order for Kendra to be able to understand all these queries and find the most relevant information as a search answer, Kendra is trained on a broad base of domains. That means that Kendra is not only suitable for search within multiple industries or verticals like financial services, pharma, healthcare, travel and hospitality, but it's also able to identify the right concepts and terminology when people within any organization asked about like health benefits or travel policies or legal documentation like NDAs. So this is really important in order to understand and identify concepts correctly and find the best and most relevant answers. As far as the accuracy is concerned, using machine learning model under the hood gives us a huge advantage because we can improve search accuracy over the time. Amazon Kendra also includes continuous improvement features that ensure such results are accurate and relevant over the time. Incremental learning comes built into Kendra and learns from user interactions and feedback. It uses these inputs to reprioritize content in the list of search results so that over time, the information that provides to be the most valuable is positioned at the top of the list. As far as addressing the complexity issue, we have taken two main approaches here. The first one thing is that you do not need to invest so much time in integration with all the data sources across the organization in order to make enterprise search works. Using connectors is a quick and easy, so you just add data sources to your Kendra index and select the connector type. So connectors will maintain document access rights and can be scheduled to automatically sync your index with your data source. So you are always securely searching through the most up-to-date content. Kendra delivers highly secure enterprise search for your search application. Your search results reflect the security model of your organization. With Amazon Kendra, data is encrypted in transit using HTTPS TLS and also encrypted at rest using Amazon KMS. Also, Kendra supports token-based user access control. So many people ask, how does Kendra compare to Elasticsearch? When do we offer which? So now we can kind of think how we differentiate between Amazon SageMaker as a machine learning stack and our AI services like Amazon Poly, Amazon Translate, or Amazon Kendra. Amazon Elasticsearch service is a lower level service or search engine that developers can use to build custom keyword search applications. Amazon Kendra, on the other hand, is a fully managed search solution. It provides capabilities such as relevancy tuning and filtering. And most importantly, it comes with machine learning models pre-trained for semantic search right out of the box. Amazon Elasticsearch service used mostly for keywords searches, things like highly performance log analytics, while Amazon Kendra can be used for natural language queries, asking factoid questions like where is, when is, how to, as well as FAQs. Amazon Elasticsearch service is used mostly for structured content. It is great with structured content because it maps those structured elements like specific entities into an index for search. Amazon Kendra is designed specifically for unstructured content so that you can ask questions and hone in onto an answer. So when you compare the two, I would say as a rule of thumb, if most of your content is unstructured and your biggest problem is search accuracy, and you don't have a real need for developing a custom search application, your best choice would be using Amazon Kendra. So you can experience the power of Kendra by accessing this link code19.aws. So it's a public website, and you can just type in code19.aws and you can type the questions there so that it will demonstrate how the Kendra can be useful in searching all this COVID-19 related information. CORD stands for COVID-19 Open Research Dataset. AWS launched CORD-19 Search, a new search website powered by machine learning that can help researchers quickly and easily search items like tens of thousands of research papers and documents using natural language questions. CORD-19 Search includes data which has been processed using Amazon Comprehend Medical. So let's look at how some of our customers have reimagined their enterprise search using Amazon Kendra. Woodside Energy is the pioneer of liquefied natural gas in Australia with 65 years of experience, including 35 years in designing, building, and operating LNG plants. They have millions of documents capturing collective intelligence. Woodside uses Amazon Kendra to help its employees working on projects in the space of natural gas drilling. Being able to find the information that they need quickly and efficiently is very important for their operations. For example, they're able to go out in the field to a drill site with the right equipment because they were able to ask a question and get a straight answer. So, for example, what is the length of the pipeline at Pluto? Provides them with the direct answer like 167 meters, which allows them to know how many valves they need to take that day to implement on that job. 3M uses Amazon Kendra to accelerate material science research. Being able to find information about prior research and know when to start, where to start, and utilizing R&D for the next research is critical for accelerating the pace of innovation. So Kendra lets 3M scientists find the information they need by handling natural language queries quickly and accurately. WorkGrid is a Liberty Mutual insurance company that developed a chatbot framework for builders. It does not require any programming or act as a cognitive assistant to help employees find information they need and carry other tasks around the organization. We have also implemented this similar approach with Amazon Lex, where Amazon Lex has the ability to identify fallback intents and call Amazon Kendra to fill in those gaps. So this is a very common use case for both internal cognitive assistant type of application as well as external self-service channel. Agent assisted with cognitive search is another example where Kendra can be quite handy. The customer connects to the agent either directly from IVR or an escalation from another channel such as a chatbot. Transcribe then automatically converts the speech to text. The transcription can be provided to both Amazon Comprehend and to Amazon Kendra. Amazon Comprehend will extract out the sentiment, entities, key phrases that can be stored along with the transcription and displayed in a dashboard. Amazon Kendra can then be used for natural language search to find the next best action. So with that, I hope this has been useful in understanding how Amazon Kendra provides highly accurate enterprise search service powered by machine learning. So with Amazon Kendra, you can improve employee productivity, you can improve customer experiences, and you can develop all sorts of cool applications that are knowledge driven. And they provide accurate answers without investing in non-core development. We have solution architects and a great machine learning solutions lab that can help you on your journey in implementing machine learning powered search. And we have great AWS partner ecosystem, specifically search experts that can help you develop connectors, run proof of concepts, and walking through the implementation process hand in hand.